Video assignment C4, the chain rule. Learning outcomes for this lesson. Following the completion of the workbook assignment and the in-class activities, the successful student will be able to 1. Calculate derivatives using A. Appropriate combinations of basic differentiation rules, the constant rule, sum rule, difference rule, power rule, constant multiple rule, product rule, quotient rule, and the chain rule. B. Differentiation formulas for functions involving a to the x, trigonometric functions, functions involving logarithms with any base, and basic inverse trigonometric functions, arcsine, arccos, and arctan. Advice for mastering the learning outcomes. The chain rule is used to differentiate composite functions, meaning compositions. A composite function is a function that can be written in the form y equals f of g of x. We refer to g of x as the, quote, inner function, and f of x as the, quote, outer function. The function y equals square root of 7x plus 3 is a composite function. With f of x equal to square root of x as outer, and g of x equal to 7x plus 3 as inner, we can verify that y is equal to f of g of x. F of g of x is equal to f of 7x plus 3, which is equal to the square root of 7x plus 3, and that's y. Notation. Another way to write a composition of f and g is using the circle notation. So f of g of x is equal to f circle g of x. So here's the main point of this section. The chain rule says to differentiate y equals f of g of x using the formula derivative of f of g of x is equal to f prime of g of x times g prime of x. And in words, the chain rule says take the derivative of the outside function, plugging in the inside function left alone, and then multiply by the derivative of the inside function. Parentheses often, but not always, indicate the presence of a composite function. Multiple sets of nested parentheses often indicate the presence of nested composite functions, meaning composites inside other composites. To differentiate nested composite functions, you must repeatedly apply the chain rule. Just like our other differentiation rules, the chain rule will often need to be combined with multiple other differentiation rules.